In this video for section 9.1, we're going to talk about how to actually conduct a hypothesis test for a mean. So we're going to start by defining alpha, or the level of significance. This here is the Greek letter symbol for alpha. Alpha is the probability of making a type 1 error, and it's going to be given to you in the problems. It's not something that you have to come up with yourself. But the idea with alpha is that a lower value for alpha or a smaller value is used if making a type 1 error is costly. So situations that are like medical situations, life or death situations, we really don't want to make a mistake in our research. We want to be sure about our results. We use a smaller value for alpha. If it's not life or death and it's not as much of a big deal, if we have a mistake in our results, then we can use a larger value. Now what we do in a hypothesis test is we calculate a p-value, and we're going to use Minitab for this part. We compare the calculated p-value to alpha that's given to us in the problem, and this tells us if we reject or fail to reject the null hypothesis. The rule is here in the bold, and I'm going to also put a box around it because it is very important. So we reject the null hypothesis if the p-value is less than or equal to alpha. We fail to reject the null hypothesis if the p-value is greater than alpha. So again, calculate p-value using Minitab, compare it to alpha from the problem, and determine which is greater. If we reject the null hypothesis, what that means is that we have evidence to support the claim, or the sample data supports the alternative hypothesis. When the null hypothesis is not rejected, that means that we do not have evidence to support the claim, and the sample data supports the null hypothesis. So here is a summary of our approach. We start with stating the claim, identifying that in our problem, and then we determine the null and alternative hypotheses. Then we find the alpha in the problem, and this is our rejection rule. Then we determine the statistical tests that we're going to use, and these are going to be the same three menus that we saw with confidence intervals, and find the p-value. So we have one sample z, which we use if we have mean and standard deviation, and our standard deviation is known, or sigma, population standard deviation. We use one sample t if standard deviation comes from a sample, and we use one sample proportion for proportion problems. And again, we're using Minitab to calculate that p-value. We use the p-value to determine whether we reject or fail to reject the null hypothesis. And based on that, we state our conclusion. And those are going to be either sentences or multiple choice in MyLab that you're going to be filling in or selecting for that part. So we're going to look at this example. We have the parking manager for the Los Angeles Dodgers baseball team who has studied the exit times for cars leaving the ballpark after the game and believes that recent changes to the traffic flow leaving the stadium have increased average exit times. Assume that prior to the changes, the mean exit time per vehicle was 36 minutes, with a population standard deviation equal to 11 minutes. To test the parking manager's belief that the mean time now exceeds 36 minutes, a simple random sample of 200 vehicles is selected and a sample mean of 36.8 minutes is calculated. We're using an alpha level of 0.05 to conduct a hypothesis test. So let's start with our claim. Our claim is that the mean time now exceeds 36 minutes. So our mean, or mu, is greater than 36 minutes. So this is going to be my alternative hypothesis. So the claim leads directly to the alternative hypothesis. My null hypothesis is the opposite of that. So it's that mu is less than or equal to 36, and these are times in minutes. So that's my null and alternative hypotheses. Now let's identify information in the problem. So we have our sample size, we have our sample mean, and we have our population standard deviation. Population standard deviation means that we use z that sigma is equal to 11. Sample mean is equal to 36.8. And n, our sample size, is 200. Finally, we have our alpha of 0.05. So we're going to go to Minitab now. We already established that we are using one sample z because we have population standard deviation. Just like before, we are switching this to summarized data since we have information about sample size, sample mean, and known standard deviation. So my sample size here is 200, sample mean is 36.8, and that known standard deviation was 11. Now I'm going to check the perform hypothesis test box, and I need to put my hypothesized mean in this box. That's the mean for my alternative hypothesis. So my hypothesized mean is 36. Then I need to click on options. I don't need to do anything with the confidence level box since I'm not getting a confidence interval. However, I do need to change the alternative hypothesis box so that the sign matches the direction of the sign in my written alternative hypothesis. So my alternative hypothesis is that mu is greater than 36, so mean is greater than hypothesized mean. Click OK. Click OK again. Now it's going to give me something here that I don't need at the top, my test. I scroll down a little bit to find the results. And I see here it's giving me the null and alternative hypothesis. The null hypothesis is a little bit different in Minitab, just the way that they write it always with an equal sign. Don't worry about that too much. Our book is using this kind of symbol where it's the opposite of the alternative. So my alternative hypothesis is mu is greater than 36. That matches up here. And the alternative hypothesis in Minitab, you'll see the symbol H1. That's also used instead of HA. Z-value and p-value. Some problems will ask you for a z-value, or if you're doing one sample t, it'll be a t-value. You might have to put that into MyLab. The p-value is what you need in order to determine whether you reject or fail to reject the null hypothesis. So 0.152 is my p-value. So I'm going to write that down here. So I'm comparing that p-value to the alpha level. So if my alpha is 0.05, which is greater, the p-value is greater. It's not less than alpha. So since p is not less than alpha, that means that we fail to reject the null hypothesis, or we cannot reject the null hypothesis. And so what does that mean about our claim? That means that we do not have evidence to support the claim that the mean time exceeds 36 minutes.